Hello everybody, I am Hemashri, studying in Sri Venkateshwara College of Engineering. Currently I am pursuing my first year BE in Electronics and Communication. Today let us know about corrosion science and its types in chemistry. In this video, let us know more about the topic. In this video, I am covering definition of corrosion, dry corrosion, wet corrosion, types of corrosion, that is of two types, differential metal corrosion and differential radiation corrosion, then the last, corrosion control methods. Let us know about definition of corrosion. Corrosion can be defined as the destruction or deterioration or loss of metals or alloys by the surrounding environment through chemical or electrochemical reactions. Example, rusting of iron, a reddish brown scale formation on iron objects. The reactions for rusting of iron are as follows: Fe2 plus 2OH minus gives FeOH twice. Then 4FeOH twice plus O2 plus 2H2O gives Fe2O3 3H2O, that is hydrated ferric oxide, nothing but the rest. The second example is green scales formed on copper vessels. These are the two examples. Corrosion may occur either in a dry environment or in an aqueous medium. The former is called dry corrosion and later is called wet corrosion. Let us know about the difference between dry corrosion and wet corrosion. Dry corrosion, corrosion occurs in the absence of moisture, whereas in wet it occurs in the presence of conducting medium. In dry, it involves the direct attack of chemicals on the metal surface. In wet, it involves the formation of electrochemical cells. In dry corrosion, the process is slow, whereas in wet corrosion, it is a rapid process. And corrosion products are produced at the site of corrosion in dry corrosion, whereas in wet corrosion it occurs at anode but the rest is deposited at cathode. The process of corrosion is uniform in dry corrosion, whereas in wet corrosion it depends on the size of anodic part of metal. Example for dry corrosion, formation of AgCl on silver metal, that is silver chloride on silver metal. Example for wet corrosion, it is rusting of iron. Moving to the next slide. When it comes to types of corrosion, it is differential metal corrosion and differential radiation corrosion. Differential metal corrosion occurs when two different dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as anode, undergoes oxidation and gets corroded, whereas the other metal with higher electrode potential acts as cathode, undergo reduction and protected from corrosion. This type of corrosion is known as differential metal corrosion. Example, tin coating copper vessel and steel pipe connected to copper plumbing. Here is a picture where you can relate it to differential metal corrosion. Differential aeration corrosion, when a metal is exposed to different concentrations of air or oxygen, part of the metal exposed to lower concentration of oxygen becomes anodic and undergoes corrosion, whereas the other part of the metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. This kind of corrosion is called differential radiation corrosion. Example, part of the nail inside the wall undergoes corrosion. And the second one, when a dust particle sits on a metal bar, the part under the dust undergoes corrosion. Differential aeration corrosion are further classified into two, that is waterline corrosion and pitting corrosion. Waterline corrosion, when a steel tank is partially filled with water for a long time, the inner portion of the tank below the waterline is exposed only to dissolve oxygen, whereas the portion above the waterline is exposed to more oxygen. Thus, the portion below the waterline acts as anode and undergoes corrosion. The upper portion acts as cathode and is unaffected. Example, if you observe in ships which remain partially immersed in the sea, seawater for a long time undergo waterline corrosion. Here is a picture where you can understand the part below the water line undergoes corrosion, whereas due to less concentration of oxygen, whereas the part above the waterline does not undergo corrosion due to the more concentration of oxygen. Then pitting corrosion. Pitting corrosion results when the portion of the metal covered by dust, which is less aerated, when the portion of metal covered by dust, which is less aerated, becomes anodic and undergoes corrosion and form a pit. The remaining area of the metal, which is exposed to higher concentration of oxygen, becomes cathodic and remains unaffected. Here is a picture. This is the iron metal. This is the dust particle which is sitting on the iron metal and forms a pit below the dust particle. Coming to the last topic of today's video, that is corrosion control methods. Corrosion can be controlled by preventing the formation of galvanic cells on the surface of metals. Here are few methods to control corrosion and can be classified as design and selection of materials, protective coatings. Here it is classified into inorganic coatings and metal coatings. The third is cathodic protection. So these are the methods used for control of corrosion. By this, completing my video about corrosion science and its types. Hope you guys understood this. If you find this video helpful, please do like, share and subscribe. Thank you.